All right, so let's take a look at this scatter plots and function fit. We actually did most of this in class, so these first 4 problems we did in class. The one that was homework was this portion, okay? So first of all, I'm going to do these ones just so we can see them, talk about them, that kind of stuff, and then we'll do the other portion as well. Okay. So roller coasters. The table and graph the graph below show the vertical drop of the roller coasters built since 1988. Okay, and we see this a lot. Notice that the 0 here actually is representative of 1988. So like if we went to 10, that would be 1998. Okay, 12 is 2000, and so on. A lot of times when we have years, we do this instead of actually writing the year. So we want to draw a line of best fit, also known as a regression line, okay, which is basically kind of like an average. So if I were to try to average out these points and draw a line, it would probably look something like that. Okay, maybe make it a little straighter here. I don't know if that was any straighter. Okay, so now what it wants us to do is to find the y-intercept, the slope, and make an equation, okay? Because that regression line is what we use to then make some predictions and try to figure out some information. So, y-intercept looks like we're probably at about 120. Okay, we kind of just estimate this. Then my slope, I'm going to pick this point right here. So we go up 130, to the right 8. So my slope would be the rise, 130, over the run, 8. Now, I can definitely reduce this, and we could reduce it to 65 over 4. Okay, so then to write my equation, because it's a linear equation, I just go y equals 65 over 4 times x plus 120. Okay, and that's all there is to it. Now, you may come up with one that's slightly different based on what you think it looks like, and that's okay, because really it's when we get to the calculator that's where we're going to know for sure what it should have been. Okay, but if we wanted to answer, now we can use this to answer. So we want to know what would be the height most likely in 2012. Well, if 12 is 2000, we'd have to go clear out here to 24 to get to 2012. Okay, so we're going to use that 24, and we're going to plug it into our equation and then solve it. So we get y equals 65 over 4 times 24 plus 120. Okay, so it's like 24 over 1. That's like 4 times 6. So I can cross out the 4's, and then it's 65 times 6, which would be 210. So we get 210 plus 120, which would be 330. No, that doesn't sound right. 6 times 6 is not 18. That's where I made my mistake. I'm thinking that doesn't look right. Because right, 330 would be like down here. And ours is going up way higher. That would be 360. So 390, there we go. So then 390 plus 120 would be 510. So according to our line of best fit, we would predict that it would be 510 feet in 2012. Okay, now we could go check that and see if our prediction was close or not. Okay, then it also says, what about predicting the height in 1998? Okay, so 1998 would be right here at 10. So I could just plug it into the formula again, right, and solve. Okay, we could do it that way, or I could just go up to my graph and kind of estimate and say, according to my line, it's probably going to be about 275 feet. So we could do it that way as well, which if we multiplied 650 times, or 65 times 10 is 650 divided by 4. We would get something like this. $162.5 plus 120 would give us 282.5, which was pretty close to our other one. So you could go with either one of those, okay? All right, so now B, insects are exothermic, meaning they're heated from the outside, not their own body. They don't make their own heat. Again, draw a line of best fit. And so if I look at this, I might go down something like that, okay? So my y-intercept looks like it's pretty much 0, 3, okay? Then my slope, okay, I've got that point right there, which I think I'd use, which we'd go up 27, 3 to 30, to the right, 30. So it'd be 27 over 30, which I could reduce to 9/10. So my equation would be y equals 9/10 times x plus 3. So if I'm checking for at 12 degrees Celsius, I'd go y equals, now I could go up here and estimate to be about 13, or I could plug it into my equation and try to solve it that way, okay? And then 9 times 12 is 108, divided by 10 would be 10.8, plus 3 would give me 13.8 degrees Celsius for the body temperature, which was pretty close to what I'd estimate if I did the graph right there, right up here. All right, so when we're guessing, that's kind of all there is to it, okay? For this one, draw a line of best fit. It'd probably look something like this, okay? So I'd maybe estimate this up to be 1,300. So y-intercept of 0, 1,300. Then for my slope, looks like I've got this point pretty good. So that would be 450 and 9, right? Day 9, that point. So 1,300 down 450 would give me a negative 850 because we're going down. And then to the right, over 9. So it would be negative 850 over 9, which I would then see what that could reduce to, right? So 850 divided by 9. Can't really reduce it at all, so we can leave it that way. I could turn it into a decimal, 94.4 repeated. That would work as well. And then I get my equation, y equals negative 850 over 9x plus 1,300. This one actually didn't have us do any work with it, though. Okay. The out-of-pocket health care cost to individual Americans has risen steadily in the last 30 years since 1980. These average yearly costs do not include health care insurance premiums paid by the individual. They're just out-of-pocket costs for doctor visits, emergency care, and outpatient procedures. Okay, so then we've got some information here about the year we're starting is 1980. That's 0, and then so on. Okay, so again, draw our line of best fit. Probably start maybe right here at 250. Kind of draw my line like that. Okay, so y-intercept 0, 250. So, looking at this, trying to find it, I've got a pretty good point right there. So 250 to 1,000, we'd go up 750, and to the right, 20. So it'd be 750 over 20, which we could reduce to 75 over 2, or that one's pretty easy to do a decimal with, isn't it? It would be 37.5. So I'd go y equals 37.5 x plus 250. Then we want to find out what about in 2015, which is 35 years on the graph. So out here at 35, what are we going to be up to? So I go y equals 37.5 times 35 plus 250. Okay, so we can just use a calculator to calculate that. And we end up with about 1562.50 cents its money. Okay, and then you can answer this one on your own. What are some reasons you think that that's happening? Okay, but there we go with that. Okay, and that's what we did in class. So now, taking a look here. So we've got a list of waste generated in the United States from 1970 to 1995, and how much was recycled. Notice it's in millions of tons. Okay, so they want us to create a scatter plot on the graph below using the x-axis for waste generated. So this is our x, and for waste recycled is our y. So we don't care about the dates. Okay, so this would be waste generated, and this would be waste recycled. Okay, now it looks like on recycled we go from 9 to 56. So maybe we count by tens. So 0, 10, 20, 30, 40, 50, 60. And then on the other one, we go from 122 to 208. Okay, so maybe we count by 20s. So it's 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, and 240. All right, then we plot the points. So the first one is 122 and 9. So 122 and 9 would be about right there. Okay. Then 152 and 15. 152 and 15 about right there. 164 and 16 about right there. 197 and 34 and 38. So 197 almost at 200. 34 and 38 about right there. 202 and 41 right there. 205 and 52 like right there. 210 and 52. Oh, 45. I messed that one up. That should have been 45, huh? It's like right there. Then 210 and 52 like right there. And then 208 and 56. So kind of like right there. Okay? So then we want to draw a line of best fit and create an equation for it. Okay? Now this is going to be a little bit tougher, isn't it? Because I'm going to want to go kind of like this, maybe actually a little bit lower, I think. Problem is, I've got to have to think negatively, aren't I? So that would be negative 10, negative 20, negative 30, negative 40, negative 50. So maybe a y-intercept of 0, negative 45. Okay, then a slope. It looks like this point and this point my line went through. So that first one was right here. And then my last one was right here, wasn't it? Okay, so x value, I'm going from 122 to 210. Okay, so if we're subtracting 8, would be 88. Okay, so we go to the right, 88, and we go up from 9 to 52, so we'd go up 41. So slope would be 41 over 88. Okay, so my equation, y equals 41 over 88x minus 45. Okay, it says predict the amount of waste recycled for 250 million tons of waste generated. Okay, so if we were out here at 250, where would we be? Okay, so I could try to do it graphically, or I could just go y equals 41 over 88 times 250 minus 45. So then I just want to use a calculator to do that, just because it's going to be easier. And we would end up with y equaling about 71.4773. So about 71.5 million tons recycled. Okay. Now it says estimate the amount of waste generated for 50 million tons of waste recycled. So now we're kind of going backwards. So in this case, the y value is what we have. So we'd go 50 equals 41 over 88x minus 45. So I add 45 to both sides first, giving me 95 equals 41 over 88x. I times both sides by 88. Okay, so I go 95 times 88, giving me 8,360 would equal 41x, because those would cancel. Then I divide by 41. So I take that and divide by 41, and we get about 203.9 would equal x. Okay, which if we went over here, seems like that would be a pretty good result. Okay? Alright, so there we go, guys. Now, let's just, I want to take this one and actually use the calculator so we can kind of see what it would look like on the calculator as well. Alright, so we wanted to do that last problem on the calculator, so I go new document, lists and spreadsheets. So we've got waste generated, which I'm just going to call gen for generated, and waste recycled, so I'm going to just say rec for recycled. Okay. Then we're going to enter in our information, right? And this is in millions of tons, so 122, 152, 164, 197, 197, 202, 205, 210, and 208. Now, since we're doing it on the calculator, we could actually put it in the millions, so add the zeros and whatnot behind it, and it'd be fairly easy to do. But because we didn't do it on the other one, I probably wouldn't do it on this one either. Okay, so then we hit Control Doc, we add data and statistics, then we go down, click to add the variable, and let's see, we wanted generated as the x variable, and then we wanted to see recycled here. And so there's kind of the look of our graph. Okay, so then we can hit Menu, Analyze, and we can go to Regression, right, and show the linear. Okay, and we end up with an equation that looks something like that, which ours was pretty close to, wasn't it? Okay. We could also notice that there is kind of a curvature to it. So I wonder what it would look like if we actually did a regression line that was exponential. To me, that one almost seems to be a better fit, doesn't it? Okay, in actually following the data a little bit more. Okay, but we can still do that one, and then we can use that to answer the questions. Okay. Okay, so there's our picture of our scatter plot and our equation. So we can see that we were a bit off on what we had, weren't we? Okay, though we did 41 over 88, which decimal wise, that was 0.465909, so pretty close. But if I were to do this using their equation, I'll just type it into the calculator. We'd end up getting 67.9 millions. So we were a little high. We could even go backwards and make this the 50 and see on that second part what we would end up with. And so we'd go 50, and then we'd add the 60.7499, and then we'd divide by the 0.514634, giving us about 215.2. Okay. So according to that regression line, a little bit off, but not too bad. Okay, there we go, guys.